So problem 2 from your kind of homework / video notes. We have I already graphed this on my calculator. There's something kind of interesting going on right around in this area of the graph. We notice here that we have an end behavior model of, let's use my blue, of g of x equaling negative 2x to the 5th power. And then, again, we know that the graph is looking something like that, where it's going to move down from left to right. The leading term is negative, x to the 5th odd degree, so the ends of the graph are going to be going in opposite directions. But we also know that a 5th degree polynomial has at most, and you should be able to fill in the blank, at most how many turning points? At most it has 5 or 4. 1, 2, 3, 4 turning points. 1, 2, 3, 4. And so we're kind of looking for 4, since we don't see any repeat factors or anything, but we can see from our graph that we don't necessarily have 4. We have 1, 2 turning points. But again, there's something kind of interesting going on right here, that certainly the graph could have 4 turning points, but just to remind you guys that we don't always have the degree, or 1 less than a degree, 1 less turning point than the degree of the polynomial. So we don't always have that, and in this case we don't. But it's worth looking at, and we'll do that in a minute. Okay, so x-intercepts. I realize that some of you already have done everything, so you probably are just fast-forwarding through this. So I can calculate 0, left bound negative 5, right bound 0. But here we have a left bound, or a guess of negative 2. Get it over closer to the one on the left. So negative 2.2, comma 0. Don't let that 1.8 e to the negative 12 freak you out. That's just another way of saying 0, but the calculator sometimes doesn't give you exact values, but it's close enough. That's a negative with a decimal point followed by 11 zeros followed by the numbers 1, 8. So that's as close to 0 as you're going to get for this particular one. So we have negative 2.2 is one x-intercept. We see another one, so I can calculate 0, enter, negative 2, comma 0. Oops, I messed up. So I can calculate 0. A left bound of negative 2, enter, a right bound of 0, enter, and a guess of negative 1. And so we see negative 1, 0. And so we get negative 1 for another x-intercept. And the third x-intercept, so I can calculate 0. A left bound of 0, enter, a right bound of 2, enter, and a guess of 1. So 1.3 would be our other x-intercept, 1.3. A y-intercept we can see of 6, letting all terms go to 0. Turning points then, let's go ahead and take a look. Second, calculate minimum, 3, so we have negative 5, comma 0, comma, guess of negative 2, let's say, somewhere around there. Negative 1.8, okay, so a turning point, negative 1.8, comma, negative 8.9, okay? So, negative 1.8, it's hard to squeeze this in there, comma, negative 8.9, negative 8.9, that's one turning point, and that's a min, so you're going to label your graph, negative 1.8, comma, negative 8.9, and that's a local min, and then we have a local max over there. So we will need to second calculate maximum, and we have 0, comma 3, let's say, and then 1 for a guess for the x value, 0.7 and 7.4, 0.7 and 7.4. Okay, so there's the coordinates there, 0.7, 7.4. All right, so we have our domain again is all real numbers. A domain, for, by the way, domain of all polynomial functions, I know I've said this, is always all real numbers, but the range sometimes changes depending. But an odd degreed polynomial, the range is always going to be all real numbers, and you should know why, because your arms are going in different directions. So we see labeling the graph helps us determine when f of x is increasing. F of x is increasing from negative 1.8. So the inputs go from negative 1.8 to 0.7. But decreasing, when are the outputs getting smaller? Well, from negative infinity all the way to negative 1.8. But also they're getting smaller from 0.7 all the way to positive infinity. We have a local min of negative 8.9. I'm just going to say of for this one. Of local max of 7.4. Okay, and the degree of the polynomial is 5. That's it.